Dhanpal, good evening. So let's move today's class. Thank you, Rohit. Good evening. So now we need to prove these things. Okay, when it is slower and all those things, we'll cover it. So now let's start the analysis. Okay, let me draw one counter. Good evening, Mohan. Arun, good evening. So let me take one count. Synchronous counter na synchronous counter. It तो asynchronous counter. So your J0, K0, 1, J1, K1. This is the standard figure. We discussed it already at that time. So this is your flip-flop 0, flip-flop 1, flip-flop 2. Q0, Q0 bar, Q1, Q1 bar, Q2, Q2 bar. Good evening, Bhargavi. This is a synchronous count only, sorry, asynchronous count only, ripple count only we are discussing. But here I want to do little extra analysis from this. Little extra analysis from this. So let's do that extra analysis. Good evening, Kumari. So now see here, this is a mod 8 ripple counter. It may be up counter or down counter, don't worry about it. Almost like now only. एक सॉन्ग और एक फाइट हो गया. You said NW means you mean networks. August 3rd, hopefully, date changed. Tomorrow I will confirm your timings also. Most probably it is from where is that? August 3rd. I means morning I'm planning. Okay. So most probably this will be our timing. Okay. Other subject I don't know. I mean, what is the plan? Maybe some slot is getting in the empty in the morning, so that's why in the morning. No, Aditya, maybe it is in the morning or evening. Most probably in the morning. I will confirm tomorrow. So first week there will be 4 hours class, like morning network, evening digital. After first week, 2 hours only. Nice. Our class will be completed, then my class will start. Okay. So for timing, leave the topic. it is we have so much of time, so we can talk later. So most probably August 3rd you can reach. Tomorrow I will confirm you everything. So now come here, mod 8 triple counter. Now it won't collide. The batch will be same. Our batch only, na. That is, if I take class in this time, at this time, no class will be there. That is same thing. For our team, then it won't clash. So now listen here. Each flip flop having propagation delay of assume TPD. Sura, mostly it is from August 3rd morning. We may start networks. Right now it is N is number of flip flops. Okay. So now listen here. See, you have a 3 flip flops. J1, these are ones. It is okay. Fine. So once you give clock to get the output here, how much time is required for me? TPD is required. Now this is clock to this. What is the meaning of propagation delay? It is the time required to get the valid output after applying a clock. After applying clock, it requires TPD time to get the output. Now I won't pass. Yes, Meghna. Now after this is clock input to this. It requires another TPD. 2 times TPD. Now this is clock to this, so this requires another TPD. Total time to get the final output will be here. How much time? Can I say 3 TPD? Everybody accept this or not? Because all flip flops will not change at a time here. Because first this fellow will get the clock, he will change. This will act clock to this, then he may change or may not change. This will act as a clock to this, he may or may not change, but it requires minimum TPD to get the valid output. Minimum in the sense, if it is not changing, no time is required, but if it changes, it requires TPD. So what is the total delay in this process? What is the total delay? It is equal to N times TPD, where N is the number of flip-flops, TPD is the propagation delay of each flip-flop. So the time period of your clock must be greater than N times TPD. Sir, why n times TPD, sir? Because once you get the output, you will read the total. Once you read the total, then only you should apply the next clock. You applied clock, this fellow changed. This fellow will give, this fellow changed. You should not apply next clock immediately. Total output comes, you will be reading or you may be doing some job, then you can give next clock pulse. So time period of the clock must be minimum how much? Greater than NTPD. So here, very important formula for any asynchronous or ripple counter, our frequency of the clock should be less than 1 by n times TPD. Or what is the maximum clock you can apply is 1 by n times TPD. This is the maximum clock you can apply for your asynchronous counter. No race condition, Pupul, because it is edge triggering, there is no question of race condition. See here, for example, wait, I will tell you, Pupul, just see. You have 3. You applied clock, it becomes 4 now. What is happening is before this becomes 4, why how it happens? First this fellow will change. First 1 TPD may this changes. This will not change by that time. Okay. By seeing this change, because of the negative edge, this fellow will change. Now because of this fellow will change. This is what's happening between 3 and 4. Okay. So what I am saying is without getting 4, you should not apply clock in between at this stage or this stage. Then this fellow will change again. Yes or no? So you should get the stable final output, then you should apply the next clock pulse. Otherwise, there is no meaning for your counter. 3 will not give you 4. Okay, because of this clock is given to only one flip flop. First this fellow change, then this fellow change, then this fellow change. The total change occurs after this time. TPD, 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 3 TPD. Then you apply next clock pulse. Then your output can change again. Before getting the steady state value, you should not apply it. This is what we call transient states. This So this is one disadvantage in your ripple counter or asynchronous counter, because all flip-flops are not changing at a time. Between one state to another state, there is a chance to get intermediate states or transient states, which can give you what? Errors in your output. So you should not, after 3, you should read 4 only. You should skip these 2 states, which are intermediate, or what we call transient states. Everybody understand this logic? Very good, very good. If we read counter output during transient state, we get decoding errors. If you read your counter output during transient states, what you get? Decoding errors. Means decoding means you are assuming 3, next state is 4, but you read it as a 2 or 0, and you may do some particular job. 3 comes, you should do one job. 4 comes, you should do one job, but you read it as a 0, and you may do some other job. These are the errors can occur if you read the system during this period. So one disadvantage here is transient states. Another disadvantage is Fmax is 1 by n TPD. It is limiting here. If n increases, frequency decreases. But clock frequency should be as high as possible. Then your operations will perform as high as possible. Your microprocessor is there. 1 gigahertz, 2 gigahertz processor is there in your computer. That clock frequency should be more. Then you will be working fast. It is limiting there. Here, this is limited by this 1 by n times TPD. N increases, your frequency decreases. So that's why you can say it is slower in operation. Now you understand these 2 points. Okay. Now let me give you one important point. What we call okay. Now let's give you strobe signal. Let me give you what is the meaning of strobe signal. So what I can do is one simple way. I will show you different ways to do this. So now I am giving the name as strobe. Sir, what this strobe do, sir? Listen here. Pandey ji is late हुआ क्या? When strobe is equal to 0, say take this as your output. When strobe equal to 0, your output will be equal to all zeros. It whatever may be Q0, Q1, Q2, it will not read. When strobe is equal to 1, your output is equal to 1 into Q2, Q1, Q0. It will respond according to your, that is during the transient, during Pandeyji, transient, make strobe equal to 0. But this is not a best solution here. Why? Sir, after 3, 4 should come. during the transient period, you are making it 0. 0 is also one state now. Yes. So this is not a best solution, but this is one simple solution. Yeah, 0 can also be one transient state, but sometimes maybe depending on your application, 0 may not be utilized. Okay, 0 may be not be utilized, or 0 will not do your job. Some cases it can help, not every case. It is not the best solution. Okay, so now see. So I will show you different ways to get this strobe, how to design the strobe and all those things. We will discuss it now. Just 1 minute. One more point. See here. Here, what is the total delay? N times TPD plus T for gate. So many. Pandiji, around 5-6 slides are done. TPD plus T gate. Okay, that is for this gate. Delay extra comes. So generally strobe will increase some little delay. Okay, so now how to avoid this 0, 0, 0 also? Let's do another way to design the strobe signal. Okay, so let's see the different ways to design the strobe signal according to your requirement. You have a counter. So you have some clock Q2, Q1, Q0. Your doubt already I have cleared, Alicha. 0, 0, 0 is also one state. That's why I said it is not a best solution. I am also not happy with that solution. So that's why I am searching for the new solution. So you have one output device. So this counter is connected to some output device or some circuit which is working. Okay. So here this device is having some enable signal. Okay. Enable signal or enable bar is there. And 1 minute. You have some enable signal. So what you do is you give this here with a name strobe and invert. What is strobe, sir? It is inversion of clock. So how it will help here? Let us see. Let us see how this fellow will help us. So let me draw the clock. Okay. So assume this is your clock. So during this period, strobe is equal to 0. That is output device disabled. It purely depends on application. This device will be disabled means it will not read Q2, Q1, Q0. So during this period, strobe equal to 1. Then output enabled and read Q2, Q1, Q0. So here, this is a TPW. Okay. So during this period, your TPW must be greater than n times TPD. Why, sir? Because During this period, your transient should complete. Transient requires how much time? You see, 1 TPD, 2 TPD, 3 TPDs are required to get the transient. So during how much time you should make it 0? That is, during n times TPD, your strobe must be 0. Minimum n TPD you should make strobe must be equal to 0. So actual clock should be n TPD, but here only on should be 1 TPD. So this method will also increase some delay. Okay, so first understand this point. When clock is 1, strobe is 0. Inversion. Clock is 1, strobe is 0. Then output device disabled. Okay, output may not read the inputs. Okay, output device may not read Q2, Q1, Q0. When clock is 0, strobe will become 1 because of the inverter, then output will read it. What I am saying is, we should design like that. During this period, your transient must be finished. How much time is required to get the steady state output is given by how much time I told already NTP. So transients, this happens na 0, 1, 1, 2, 1, 0, 0 mein you get 0, 1, 0, 0, 0, 0. After you will be getting this final answer na. This all transition should complete during this period itself when strobe is 0. So when you get the final output, make strobe equal to 1. Okay, is it clear what I am saying? Lucky, is it clear now? The transient part should be finished when clock is equal to 1 itself. So it is indirectly increasing the time period, no doubt in it, which may increase your delay. I already told you strobe will introduce some extra delay. Yes, we increase the duty cycle, but this off time should be at least some part will be off now to read the data. System also requires some time to read the data. That time should be there. This is one method. So let me give you another way also. If you take T clock greater than TPD, double TPD, okay, you take this as 2 TPD, this as 1 TPD. Then what happens? The transient will occur during this period. Because your transient will occur for 3 TPD. After that, you get the final answer. We should read only final answer, not in between. Yes or no, Aditya? Let me give you one more solution. Say you have Q2. Give this to one minute. Let me complete. You take one latch. Okay. Here, this is the easiest, simplest way to design. Like this, you take outputs. This is the best way. So here your counter output will come. This is the original output you take. So when strobe equal to 0, when strobe is 0, what happens? Strobe 0, that is enable equal to 0, latch will not read. Okay, your output Q equal to Qn, no change. That is previous value. When strobe equal to 1, your Qn plus 1 equal to your output. Okay, that is a counter. This is a counter output. Okay, so this is another way. Here please listen. This disadvantage will not be there. It will not become 0 in between. But it becomes when strobe 0, it will stay in the previous value. Say it is 3. You make strobe 0. then it will stay at 3 only. When you make strobe 1, it will read the new value and it will give you. It will not read, it will not make output 0 here. That is the difference. You understand? 3 different ways to do it. First one is when strobe 0, it will become 0. Strobe 1, it will read the data. Here, simply clock is your strobe. Okay. So when clock is 0, you will get 1 here. Okay. Clock is 1, you will get 0. Like that, it will be doing its job. So during the clock equal to 1, this fellow will change. At that time, this fellow will be disabled. When this is a stable state, then it will read the data. Okay. What is your doubt? Please ask. Yes, when strobe is on, transient should not occur. That is the purpose of the strobe. Na? Strobe will off your system during the transient period. That is the simple thing. Abhinav, it will not occur because clock is 0. Unless clock is 1, it will not change your outputs. It cannot. The output device can be anything. When it is enabled, it will read. When it is disabled, it will not read. What is there in this output device? No one knows. You assume any output device. Here there is no case of strobe and transient. Here we are not worrying about transients. When you don't worry about the transients, the formula is the time period of the clock is greater than NTPD, because you don't know how you are designing your strobe signal. Okay. So firstly, everybody able to understand this or not? 3 is there. 3 is becoming 4. Okay. What is the intermediate process for 3 to 4? This is you take Q2, Q1, Q0. Okay. So it will take, first you apply clock, it will take 1 TPD to change this from 1 to 0. At that time, already this 0, 1 will not change immediately. Okay. Next, it will take 1 more TPD to become 0. Okay. It will take 1 minute. Let me do that. It will take 1 more TPD to change this to 10. When this becomes 10, it will give trigger to the next one. Then in another TPD, this will also change. 1 minute, let me write clearly. It requires 1 TPD to change from 1 to 0. By that time, this will not change. Now, it requires another TPD to change this also to 0 to 1, previous bar, because it toggles. So, to change from 3 to 4, what you are getting is, it requires how many TPD? N TPD for transient states. Okay, this is the stable. This is the stable state. In between, you are having transient states. Strobe is not detecting transient. We should give strobe some time. Okay, yes, your question is correct, Amitabh. This is the simplest way, such that, okay, before first clock may, whenever clock comes, we may give strobe. like clock inverse. You can do like that. You give strobe equal to 1. Okay, you measure such that here the strobe signal should also have that what we call. We should wait for 1 NTPD to give the strobe signal. We should have some circuit which can do that job. Okay, so what is the total delay? It is NTPD plus time delay of the gate. Manually, Amitabh. Okay, you should have one circuit which will be 0 for minimum NTPD. According to your system, you should maintain something. You do anything, maintain minimum NTPD. During the transient, how much transient is for how much time? NTPD. After NTPD, your system is stable. So strobe must be 0. That is your job to design it. Okay, you should make your strobe to be 0 for how much time? Minimum N times TPD. Okay, minimum N times TPD means greater than N times TPD. Yes. In this, any doubt, please ask. Then I will move to the next slide fast. Here, strobe is not completely avoiding transient. Okay. Why? What happened to you, Harshvardhan? It is a counter. For present state is 3. Okay, please follow the class. This is the next state. After 3, what is the next state? 4 only, na? So in between, whatever you get called as what we call transient states. Okay, good. So simply NTPD. Your time period may be more than NTPD. That is okay. Okay, you should wait for minimum NTPD. Here time period will be NTPD plus gate. Total delay. Next. In this figure, any doubt, please ask. No, it depends on this device. This device is disabled means no connection with this. Okay, this device is disabled. Read it. Device. It depends on this device. Say it may be. Maybe mux is or a decoder circuit. It is disabled means it will not read. That's all. It will not read the data. It depends on your application. Any other doubts here? From where you are getting outputs? Who is that? From counter. You people are concentrating more, okay, on unnecessary information than our useful information. You assume this is your counter, it is connected to some circuit. Okay, you are reading this counter. It depends on the device. This device is having some enable input. When it is enabled, it will read. When it is disabled, it will not read. Okay, that is what you need to know. What is inside this, sir? Why it is blue? Why it is white? Is not required for us. Okay, that's what I'm saying, Bubble. This device can do any job. That is not your business. It may not give output, it may turn on the LED, it may do something as per its wish. It read counter and it do some job, that is its job. Whatever here, it doesn't matter. Now, in this slide, any doubt, please ask. This is the easiest one or the best one, but here more hardware is required. Delay may not increase here, but the problem is what? Hardware required, or latch delay extra will come to get the final. But here, when latch is disabled, it will keep the previous state. When latch is enabled, it will be reading the data. You can also keep here edge triggering, directly give clock to this also. Then every positive clock, it will read the data. By the time already your system is stable. No extra delay. Okay, here it is level triggered with strobe, or you can also use a D flip-flop. Both are okay. It depends. But when you go for more and more hardware is required for us. So let's move further. Let me give you these points on a single slide. Strobe signal can be used to avoiding decoding errors of the transient states in the ripple counter. When strobe is 1, output may be enabled, and strobe 0, output may be disabled or made 0 or remains in the previous state according to the application. According to your design, we will make it. Strobe can simply equal to clock bar. That is, when clock 1, counter works, and clock 0, then strobe equal to 1 to read the output provided. Clock equal to 1 for minimum n times TPD. Strobe may introduce some extra delay. That's all. These points I have discussed just now. So let's move. Thank you. Now, non-binary counters. The next topic, non-binary counters. Ones, 0 to 7, 0 to 15, anything. 4 zeros to 4 ones, 3 zeros to 3 ones. So 0 to 2 power n minus 1. These are called binary counters. If you have the count other than 0 to 2 power n minus 1, it is called non-binary counter. What is the need for non-binary counter? Say, for example, you have designed one digital clock. Say you have 5 bits digital clock. Okay, 5 bits are there. 5 bits means 2 power 5 is how much? 32. Okay, it is showing your hours 0. Every hour I am giving one clock, it is moving next 1 0, it is displaying. Okay, 1 0 means take it as 2 only, some conversion decimal requirement. So next 3, 4, like that it counts up to 23 hours. Similarly, one counter may be required to count the minutes also. So here for this counter, time period is 1 hour. Every 1 hour I should give one clock. Okay. So now what happens after 23, your counter is doing 24, 25, 26, 27, 31. Because I have 5 bits, I can read all zeros to all ones. 5 ones is how much? 31. So 31 के बाद 0 हुआ. So no one will buy your clock. Yes or no? Your clock should count here from where to where? 0 to 23. After 23, it should become 0 on its own. Okay. So this is the need for what? Your non-binary counters. Every time you may not need 0 to 2 power n minus 1. So you design some calendar months are there 1 to 12 only. Here 0 month is not there. Okay, so you may not start from 0 every time. You may start from the middle, you may start end something. It depends on your application. Every time you may not be counting from 0 to 2 power n minus 1. You may start from other than 0, you may end from other than 2 power n minus 1 depending on your application. So that can be done with the help of what? Non-binary counters. So let's do that. Okay, so let's move. Next. So let me design one non-binary counter, that is 1 is not in power. What happened? Yeah. Sorry. Listen. 2 power n minus 1. Thank you. I'm just checking who is that one who is not in power. Right. So now let's make a decade counter. Decade counter or BCD counter or mod 10 counter. All are same. BCD counter, decade counter, mod 10 counter, all are same. Okay, so what is my need here? My counter should count Q3. Let me write Q3, Q2, Q1, Q0. My counter should count from all zeros to all ones. 4 bits. Okay, let me 1 minute. Let me make a little extension. 1 minute, 1 minute, 1 minute. Let's have one more box. Okay, so this is your J3, K3, Q3, Q3 bar. Now new flip-flop is added. Okay, are you ready? How many are there here? 4 flip-flops are there. Okay, originally it will do mod 16. Originally it will do mod 16. So let's make it Q3, Q2, Q1, Q0. Okay, so can be all zeros too. Let me write me. All zeros. Then 0001, then 0010, 3, 4, yeah, whatever, 100, 101, 110, 1, 1, 1, 8, 9, then 10 also. But I need my counter to count 0 to 9 only. So then what I will do is I will design such that it should at 10 it should become 0, 0, 0. When 10 comes immediately it should become 0, 0. For that what to do, sir? We should take one extra input to the flip-flop called as clear input. Now we should take the flip-flop with the clear input. Okay. So now this is the clear input I will give. I have taken active low. So first listen. Whenever 1010 comes, 1010 means Q3 must be 1, Q2 must be 0, Q1 must be 1, and Q0 must be 0. Just wait. Okay. So for this, what to do? It is 1. Take one NAND gate. It is 1. It is 0, 1, and 0. Understand? When you get 1, 0, 1, 0, then it will give clear. To observe, I am giving you. Actually, bar is directly available here. Okay, for better observation, I'm drawing like this. Very good. Now, so I have taken active low. That's why AND gate. Otherwise, it will be AND gate. I will explain everything. Just wait for 1 minute. Now, this is what we call mod 10 counter or decade counter or what we call BCD counter, which will count from 0 to 9. So when 10 comes, when 010 comes, it will immediately give 0 here. So please listen here. Whenever you get 1010, immediately it will give clear to all the flip flops. Then it will clear everything and immediately it becomes what? All zeros. It will become all zeros. Then next clock onwards, immediately it will not wait for clock. Clear will happen immediately. So the next clock onwards, you get what? 0001, 0010. Same story will continue. So this is your clock. Let me write something little. 1 minute, please. FF3 that does not require. What is the problem? Bubble is there. Okay. 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 Why we choose 1010? Because it is mod 10. It should count 0 to 9. After 9, it should 10 comes. It should be there. Because our design is for mod 10. Uh, 1 minute. Right. Kushi? It should, if you have a gate with 0 delay, everybody use the same gate. It did not be 0. It will increase the delay. Accordingly, we should increase the time period of the clock. We should adjust according to the situations. Okay, Rohit? Clock 0. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again 11, 12, and so on. Okay. Just wait, everybody. Now you tell me, you started with 0. When you got back 0? 0 से कितना clock pulses required to get back? 1 to 9, 10 clock pulses. So that's why it is mod 10. It is counting from 0 to 9. If it is counting 0 to 9, then it is coming 0, then it is called mod 10. 0 is also one state. Okay, so now you people will have some doubts. All doubts will be cleared with these examples. Just wait for some time. You may have the doubts, sir. Why NAND gate? Well, listen here. I told just now what is that. All your doubts will be cleared. Just wait for some time. Okay, Saurav? So now see here. I already know the doubts you will get. So the design is originally like this: Q3, Q2 bar, Q1. I just told what, please follow that. Wait for some time. You can see here one more application, one more observation. What is that observation? Is out of the total 10 states, not all are ones. You see here, because you have not used all the 15 states or 16 states, you need not read all the 4 bits. Here there is a chance to read only these 2 bits, only these 2 bits. You observe, these 2 are ones only for 1010, not for any other case. Correct or not? From here to here, it is not for any other case. So you can design the clear with Q3, Q1 also. You can also take Q3. What is NAND gate? What is NAND gate? NAND is nothing but bubbled input OR gate. What is NAND gate? Bubbled input OR gate. So can I draw this as bubble? You take it back. Q3 bar, Q1 bar with OR gate. OR gate. So all these are trues. You can also take AND gate also. Q3, Q1 with AND gate if active high. This is for active low. Why only AND gate? Why only NAND gate? Because it should clear only for one case, not for any other case. For example, it should clear, it should make it 1 only when it is 1, 1. Okay, if you take OR gate, it will give 1 for not only this, remaining cases also. Similarly here, why NAND gate? Because NAND gate will give 0 when you have all ones in the input. 1010 bubble will make 1111. It will become 0 here only for 1010, not for any other case. That's why we choose NAND gate. Then we made that conversions for taking the bubbles back and doing all the job. Here also, OR gate is taken. These two should be 0, 0. Then only it will give 0 and clear. Here your job is to give 0 only when this condition is satisfied, not for any other condition. Then you may have the doubt this one also. Sir, 1, 0, 1, 0 may you need not clear all the flip-flops now, sir. Because this is 1, 0, 1, 0. Already Q1, Q3 are at 0 only. Yes, clear only Q2, Q0 sufficient. Because already these are at zeros now. So you need not worry about them. You can clear only this also. Okay. Sometimes examiner may give you preset. Clear is given to make it 0. Preset will be given to make it 1. All are correct. All are correct. He may give you preset. I mean, in the sense, depending on the down counter or up counter and all those things, he may give you preset. Suppose here preset is there, we make it 1. Clear is there, we make it 0. Instead of making all 0, you want to make all 1s, you can give all presets. Or some 1s, some zeros also possible. Accordingly, we will make our designs. So now your game is only, this part is the same now. This is what we discussed till now from yesterday, day before yesterday also. Only difference is in this feedback gate. Only difference is in feedback gate. So only feedback gate you need to design. That is how you convert any counter into any number. For example, see here, you want to 11. When 12 comes, it should give you clear. 12 means 1100. So you can write it as Q3, Q2, Q1 bar, Q0 bar. Then it should give you clear. If it is active low, NAND, active high, AND gate. It is up to you. You can also prove like that. In the first 12 states, these two will be one only for 112. So you can write it as Q3, Q2 with clear. Okay, similarly, you want to make any counter, mod 14. So mod 14 I want to make. 0 to 13 it should count. 14 comes clear. 14 is what? 1110. So you can take Q3, Q2, Q1, Q0 bar and make it clear. Or you take Q3, Q2. These three are ones, then also it will be. Okay, so like that you can design any mod. For example, you want to make mod 5. You count, which will count from 0 to 4. 5 comes, you should give clear. Okay, so 5 means what? 101. So Q2, Q1 bar, Q0. Give it to clear. Or in the first 5 states, you check it 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. You see, these two ones will not occur anywhere. This is the yes or no. So you can prove it as Q2, Q0. Okay. Mod 5 cannot be made with 2 flip-flops, Rishi. How will you make? 5 states. Okay. So now you understand. Anyone having doubt, now you ask. So chalo problems karega. What is your doubt? So starting B from 0 only. Generally, examiner will give you nothing is specified. We take it as all zeros. Generally, for up counter it is 0. For down counters all ones. Nothing specified. We should take it like that. So let's do the question. When clock 1, please listen. Here Q0 toggles on every clock now. So make it 0, 1, 0, 1, 0, 1, 0, 1, 0. Next, listen here. What about Q1? Q1 toggles when Q naught is equal to 1. When Q naught is equal to 1. Q1 toggles when Q naught is equal to 1 and the clock is applied. Okay. So, why it is 2 times 0 is taken here? Naught is equal to 1. So it is a, see here, when Q naught 1, it will not toggle, it will be same. In the next, when you apply the next clock pulse, it will toggle. When this is 1, it will not toggle immediately. Next clock, it will toggle. When it is 1, next clock toggle. When it is fellow will be 0 only. When 3, 4, 5, 6, 7, 0. What is this counter? Mod 8 up. Okay, so it is proved, it is working like a mod 8. How to design this, sir? Why you are directly giving the figure? I will tell you. Tomorrow class, we see how to design the counter also. Today, our job is to prove that it is a counter. I mean, it is a up count. Tomorrow, I will show you how to design not only JK with any flip-flop, any counter. So, sir, please Q1, Q2 repeat. Please listen here. Aditya, this is the point. Q1 toggles when Q0 is equal to 1. Make Q0 1 and in the next clock. Because the clock should be applied. Earlier, clock is Q0 itself. So when it changes, immediately it changes earlier. Now, when Q0 1, not immediately. In the next clock it will change. When Q0 is 1, okay, input is ready. Simple rule. Input ready. No, clock should come now. Then only he will change. So next clock is applied, then only he will change. So let me explain you with one example here for better understanding. So initially you assume it is in 3. What is it? It is in third 0, 1, 1 state. Now listen here. 0, 1, 1. This is 1 into 1. What is the answer? 1. Your first thing you should do is make inputs ready. Input is ready. Input is ready. Input is ready. Give the clock. When 1, it toggles. So it is earlier 0, 1, 1. Now it becomes 1, 0, 0. Is it clear? So input ready, it will not change. Once you apply clock, it will change. Okay, one thing. So some people will confuse like this. Sir, suppose you do analysis from this side. What is the problem? 1, 1 becomes 0, na? Then you will problem, confusion starts. Sir, here this flip-flop, the input is 1 or 0. Or can I take this 1, 0 as a 0 and take it as 0, 0 and no change? No. Please understand, by the time you are applying the clock, already existing only will give you the output for next. These things comes now, this will change again. That will come in the next clock pulse. Okay, so input is ready, no problem. Clock is applied, then only it will change. Is it clear what I'm saying? It is 0, 1, 1. Okay, make inputs ready, apply the clock. Once you apply the clock, this 1, 1 will give you something here. This 1, 1 will give you something here. This 1, 1 will give you something here. So that's what I told. If you analyze the synchronous circuit, avoid confusion. Always analyze from which side? Rightmost side. If you analyze from this side, now you never confused. What I did to see, I made the inputs ready, then I change this first, then this first, then this one. Then what happens? There is no chance of getting confusion. If you change this one first, now you end up with confusion. You should take 1 or 0 here. Mismatch between us. I never said there is no up-down counter in your synchronous. Synchronous can do random also. It doesn't mean it cannot do up-down. Triggering concept here. Triggering does not have anything. Design is important. That we discuss tomorrow. That's why I'm saying how to design this, how to calculate its delay, everything we discuss it tomorrow. Now these points are valid or not, you see. By the time we are applying the input, already existing will give the output. After the clock, if input changes, it will not reflect in the same clock. It will reflect in the next clock. Only one change in one clock. Okay. So here, if you want to calculate the delay, what is the total delay? TPD plus T8. Here not NTPD. Here earlier it is NTPD. Here only one TPD because all changes at a time. Plus this external hardware delay. So it is faster or slow? All will change at a time. So only one TPD will reflect. First and Fourier 7 or 6. So it is having a less delay, so faster, no transient states. You may require extra gate. Earlier you don't require this. So tomorrow what I will do is I will again come with this figure. Tomorrow starting you don't miss. Come on time. Then what is your doubt, Prasad? Aditya, what is Q2 please? You are asking Q2. It is 1-1. If you apply clock, JK flip flop will change. What is the problem in that? There is no rule. Okay, this is to avoid your own confusion. Aditya, this output, this input will change this output, this input will change this output. If you analyze from left, first this you will be changed. Once you change, you will be confused whether to read 1 or 0 here. Similarly, once you change this 0 comes, you may be confused whether to take 1 or 0. This confusion should be avoided. For that only take analyze from the right side. We see mod 16 or any counter, how to design with any flip flop, everything we discuss tomorrow. Thank you. Good night. Good night. I have one more session, that's why little hurry. 10 o'clock I have one revision session. Chaitanya, if you have revision doubt, you can come at 10 o'clock. Special class is there. No topic. Okay. This month I am this one. Oh, that is not in my hand, Aditya, because similarly I will check. So I will be there for the following our morning. Some clash will be definitely there. Man, for English before September 42 evening. Good night. Good night.